classifications, I
Yeah.
think that the
Anything
types
you
of
know about it?
oxygens or oxides in carbon,
Carbon 2 oxide or
like
carbon 4 oxide.
or
Okay.
carbon monoxide.
Okay, fine, fine. So,
Component of carbon and carbon
okay,
dioxide.
fine. So that means you have an idea of what oxide of carbon is. Simply put, when you say carbon, oxides of carbon, those are carbons, right, that have in them oxygen. Okay, so carbons that have in them what oxygen, and they are basically of two different forms. We are going to look at that later. So, um, introduction. Carbon forms two stable oxides. What are the two oxides of carbon? You have the monoxide, in which its oxidation state is +2, and the dioxide, in which the oxidation state is +4. So the first one, which is called monoxide, we call it CO, or we call it carbon monoxide. Carbon monoxide or carbon 2 oxide. Why do we say carbon 2 oxide? Because the oxidation state of carbon there is 2. If you go back to calculation of oxidation number, you get to realize that when you want to compute the oxidation state of carbon, you're going to get what? That of carbon monoxide to be 2. So that's why we call carbon monoxide carbon 2 oxide. And if you look at the other oxide, which is called carbon dioxide, the oxidation state of carbon there is carbon 4 oxide. And as a result, carbon dioxide is called carbon 4 oxide simply because the oxidation state of carbon is +4. Is that clear? Is that clear?
Yes, sir.
Okay. As you can see here, we can have the formation of CO2, carbon 4 oxide, carbon dioxide, and we can also have it in the formation of carbon monoxide. So, preparation of carbon dioxide. How is carbon dioxide prepared in the laboratory? So, let's talk about the laboratory preparation of carbon dioxide. This was first observed by von Helmont towards the end of the 16th century. He was the first person to come about the idea, right? He observed it, but it was not propagated by him. So he never propagated it, but he actually was the one who made a very massive attempt of producing carbon 4 oxide from simple components. So in 1755, a scientist by name Joseph Black was the first scientist to prepare carbon dioxide or carbon 4 oxide in the laboratory by reacting dilute acid with calcium trisulcarbonate 4. So if you recall, in some of the things we've done before in acid, base, and salt, in acid, we said that one of the property of acid is that acid reacts with metallic carbonate to give us carbon 4 oxide. If you remember vividly, one of the properties of acid is that acid reacts with metallic carbonate to liberate CO2, carbon 4 oxide. So that procedure or that property can be used as a technique or as a method for the preparation of carbon dioxide. So one of the ways by which you can prepare carbon dioxide is simply reacting any dilute acid, right, with calcium trisulcarbonate 4, which is called marble, right? So let's look at how that equation can be formed. You can see there that carbon calcium carbonate, which is calcium trisulcarbonate 4, when reacted with acid like hydrochloric acid, so it's going to give us what? Calcium chloride plus water and carbon 4 oxide. So if you can remember vividly when we are talking about acid too, one of the chemical properties of acid was explicitly this type of reaction, and that shows the evolution of carbon 4 oxide. So here we have carbon CaCO3, carbon 4 oxide reacting with HCl to give us calcium chloride plus water and CO2. Oh, by now, I don't want to believe that there is anybody who should not be able to write this equation appropriately, as we have done this extensively in our previous classes before now. So how calcium carbonate became CaCl2? Because the oxidation state of calcium is 2 plus and Cl is minus. Exchange of it gives us CaCl2 and so on and so forth. So we proceed. How is carbon dioxide then collected? Carbon dioxide is collected over water by a process we call downward delivery, or by a process called downward delivery of gas, because carbon dioxide is denser than air, and because it is denser than air, if you have to collect it, you can collect it over water. One, because it does not mix with water, it is insoluble in water, and you can collect it also by a method called downward delivery of gas, because it is less dense than air. So this illustration shows how we can prepare carbon dioxide in the lab. So how is that done? As you can see here, we have marble chips. Marble chips stands for carbon dioxide, or carbon marble chip stands for calcium tricarbonate 4, CaCO3, right? And then you have dilute hydrochloric acid, which is called HCl. HCl. So when dilute acid, HCl, is reacted with calcium tricarbonate 4, CaCO3. So what happens is that we are going to have a complete reaction, and then CO2, which is carbon dioxide, will pass through this delivery tube, penetrate into the water through the beehive tube, and then it's going to be collected over water. So the gas you see up here is called carbon dioxide. So that is the procedure used in the preparation of carbon dioxide. So the composition of carbon dioxide in the atmosphere is about 0.03% by volume. We know that. And it is a colorless gas, it is an odorless gas, which is denser than air and slightly soluble in water. The solubility of carbon dioxide is very minimal. So that's why sometimes you even say it is insoluble. But it is actually soluble, but the solubility is very, very, very slight. So solid carbon dioxide is called the dry ice, and it has a tendency of undergoing a process called sublimation. That is, it can change directly from solid to gas. So what you can see here is telling us little description about the physical properties of carbon dioxide. So the physical properties of carbon dioxide include: one, it is a colorless gas, is an odorless gas, it is denser than air, and it is slightly soluble in water, right? And it can sublime. It can sublime.
So,
That means it can solid. Yeah, somebody saying something.
so please, I don't understand the how this diagram relates to what
How what?
um
How what?
I don't want to understand the diagram.
You don't understand the diagram.
That's
Are you just joining the class? Are you just joining the class?
no,
So I'm
no.
explaining. I'm explaining this. What I'm. Let me go back. And what I'm doing is I'm explaining the process of laboratory preparation of carbon dioxide. That's where we are, right? So this diagram is just telling us how carbon dioxide is prepared in the lab. We've looked at it before now, that you can prepare carbon dioxide by reacting any dilute acid with calcium tricarbonate 4. Let me go back quickly. I don't know what's wrong with my system. I think I'm having issues with that. So so as a result, we have we have Yaumna, Yaumna, Yaumna. Sorry, please. So we have the reaction of calcium carbonate. When calcium carbonate reacts with HCl, that is CaCO3 with HCl, it reacts together to give us CO2, which is carbon dioxide, as one of the products, right? So carbon dioxide, when produced, it's going to be collected up here, where we can see where the point where we have that gas. So that's where it's going to be collected, because it is done as a result of a reaction between HCl and marble chip. And he said marble chip is what? calcium carbonate, calcium trisulcarbonate 4, CaCO3. So don't worry, I will still do a little revision or summary over it. So what are the chemical properties of CO2, carbon dioxide? Let's look at some of them. Number one, acidic property. Carbon dioxide is carbon dioxide. When carbon dioxide is dissolved in water, it's going to form triazocarbonate 4 acid, that is H2CO3. It's also called carbonic acid. So it's a weak type of acid. You remember also in SS1, we talked about oxides of non-metals. We call them acid and hydride. So we said acid and hydride are oxides of non-metal, which when react with water forms weak acid, right? So when you have acid and hydride, hello, sorry, please, can you hear me? Okay, fine. So the very first one is reaction of carbon dioxide with water. So when carbon dioxide is reacted with water, it's going to form an acidic solution, which is called a carbonic acid or triazocarbonate 4 acid. It's a weak acid, which is called H2CO3. So, and if it is acidic, what's it going to do? It's going to turn blue litmus paper red, right? So that's one of the property of one of the chemical property of CO2. It reacts with water to form weak acid, so it has an acidic property. Number 2 here, we have, to continue on that, the acidic oxide turns damp blue litmus paper to red. So it's going to turn blue litmus paper to red. And in addition, because it is now acidic, it can react or neutralize with any alkali to form carbonates, to form carbonate 4 solution. So we can have this reaction also used as a test for CO2. So for example, the above reaction is used as a test for carbon dioxide, to test for carbon dioxide as a gas using lime water. You remember that we said one of the ways by which you can test for CO2 is by pumping CO2 in lime water. We did that experiment while we were in school, if you remember vividly. So when CO2 is pumped in lime water, it's going to turn lime water what? Milky, right? Do you remember that? Do you remember that?
Yes.
Yes.
Mm.
Yes.
Yes, sir. Yes, sir.
Okay. Now we have CO2, which is carbon dioxide plus water, reacting together to give us a carbonic acid. Hello? Please, can you hear me? Can you hear me?
Yes, sir.
Okay. Now you remember the experiment we did in school to confirm for CO2, passing CO2 in lime water, which is calcium hydroxide, to give us what? Milky solution, right? Do you remember?
Yes.
Yeah, so that's just a test for CO2. So you can see that we are coming to that again. Yeah, another chemical property of CO2 is that when burning magnesium, you know, CO2 on its own generally, CO2 does not support combustion. But it is quite amazing that when you burn magnesium, when you light magnesium, that is, you burn it, and you place it in a jar that contains CO, carbon dioxide, it's going to burn, and it's going to form a flame, and that's going to burn for a while, supporting combustion minimally. So that means that CO2 has a special kind of reaction or behavior with what? Magnesium. And we are doing that reaction, you are going to have a black speck of carbon formed, which is going to be seen inside the gas jar as the reaction is proceeded. Now, you have carbon dioxide is also able to oxidize red hot carbon. to carbon monoxide. So what we mean by this is another chemical property of carbon dioxide is that when carbon dioxide is reacted with red hot carbon, it's going to oxidize it, and it's going to reduce the oxidation and then lead to the formation of carbon monoxide. As you can see in the equation, carbon dioxide plus carbon, which is a red hot carbon, to give us what? Carbon monoxide. So we have that. Now, can I proceed? Can I proceed?
Yes, sir.
Here we have uses of carbon dioxide. We want to check some of the uses. What do we use carbon dioxide for in nature? I'm sorry, in life, in industry, or home, and so on and so forth. Number one, production of carbonated drinks. It is extensive. Carbon dioxide is extensively used in the production of carbonated drinks. So many a time when you open your soft drinks, you hear a fizzing effect, effervescence, evolution of gas. The gas that is coming out from your drinks is as a result of carbon dioxide. So carbon dioxide is pressured into those drinks to make the taste, to retain, or to make the taste of the drinks to be refreshing. So you can see it here that it is used in the manufacture of aerated or carbonated water. The gas dissolves in water at high pressure. It gives the water a pleasing taste when the pressure is released, or by opening the bottle. That is, by opening the bottle, the gas escapes, giving the drink its fizziness. So as from today, you should know at the back of your mind that the gas that is coming out from our soft drinks, our carbonated drinks, is carbon dioxide. So that's one of what we use carbon dioxide for. Secondly, it's also used in fire extinguishers, as you can see it here. So carbon dioxide does not support combustion. We said that. And it is denser than air. We said that. It is used for extinguishing fire. Because why do we use it for extinguishing fire? Can anybody tell us the reason? Why we use carbon dioxide for extinguishing fire? Can anybody give me the answer to that?
Please repeat the question.
I said why is carbon dioxide used as for extinguishing fire? Can anybody give me the response to that?
Yes.
Why is carbon dioxide used for extinguishing fire?
It is a heavy gas.
It's a heavy gas. Any other contrary answer or opinion? Any other person?
Does not support combustion.
Okay. Now, the reason why carbon dioxide is used for extinguishing fire, they use it in making fire extinguishers, is simply because carbon dioxide does not support combustion. It does not what? Support combustion. Okay. It does not support combustion because when you have a burning effect, combustion process, right? You need something that will cushion the effects of that. I mean, that will remove the effect of that combustion to stop the fire from continuing. So that can be done by using what? Carbon dioxide. So for example, when you have, when you lit a candle, right, the candle will be burning, but if you decide to place a pot or something over it to cover it up, so within little time, what will happen? That fire is going to go off. The reason why the fire is going off, because there is no oxygen for the fire to use for combustion. So the little oxygen that the fire had for the process has been used to form carbon dioxide, and that carbon dioxide is now extinguishing the fire. So that's all. So, but one type of extinguisher contains carbon dioxide under high pressure, and this is what we are talking about. This type of extinguisher, we have this in school, and I think I've shown you before. We've used it before in school partially. All right. So when you press it, what will happen? You are going to see a whitish substance there. That whitish substance is called the dry ice, and the dry ice is carbon dioxide in solid form, and it is used for extinguishing fire. Okay, so that's what is present in the fire extinguisher. So, and another form of existence of our fire extinguisher in another form is that it can be done by making a solution of sodium carbonate with sulfuric acid. This one is commonly used by, fire extinguishers when they go, when those who go to places where we have large fire accidents, and you see them pressing the knob of um, the knob of their host, and making sure that they center that water, that solution, over the place where the fire is coming out in. So that process is different from this fire extinguisher that we know. So there are two different processes. The other one is made up as a result of two different solutions. Those are sodium carbonate, that is Na, Na2CO3, sodium trisulcarbonate 4, and sulfuric acid, which is called H2SO4, tetrasulfate 6 acid. So when the two mix together by striking the knob, or by striking the knob of the host, so there's going to be a mixture of the two solutions, sodium carbonate and H2SO4. So you can see that sodium carbonate is a metallic carbonate and H2SO4 is an acid. So when acid reacts with metallic carbonate, what happens? CO2 is going to be produced. So while that is done, the CO2 that is now produced is mixed with the liquid in form of its pressure. So when they press it and center it over the place where there is the accident of the fire, the CO2 present in it is going to serve as a cover-up and then extinguish the fire. Is that clear? So we have two major uses of carbon dioxide here, which are stated: used in the production of carbonated drinks and also used in extinguishing and used in the manufacture of fire extinguisher. But these are not the only two uses. We have several other uses. Let's check more. All right. So number 3, it is also used as a refrigerant or coolant. Right? Solid carbon dioxide, which is known as dry ice, is formed below minus 78 degrees Celsius. When it burns into gas or sublimes, it leaves no residue. And thus a better refrigerant than ice. So we use it basically also for preserving, for refrigeration of perishable foods such as ice cream. So what they actually use in large industries where they make ice creams is actually dry ice, which is solid carbon dioxide or carbon 4 oxide. So we also use this same dry ice also as a coolant in nuclear reactors, especially where they make use of nuclear energy to produce nuclear energy for consumption of the society. So they use it a lot to cool because it emits a lot of energy. So as a result, they use it in cooling the effect of the evolution of energy that is produced during that process. So you've been able to mention 3 uses of carbon dioxide in our discussion. One, we said carbon dioxide is used in production of carbonated drinks. 2, it is used in the manufacture, it is used as a refrigerant or as a coolant, and also carbon dioxide is what's the third one we said? Can anybody remind me? Can anybody remind me of the 3 uses of carbon dioxide that you said?
It can be used as
It's
extinguisher,
used to make carbonated drinks. It can be
Number
used
and
1.
it
to
can be
make
used for making
extinguisher.
carbonated drinks, and it can be used as a refrigerant or
That
coolant.
Used to make fire
refrigerant or coolant.
extinguisher.
Thank you very much. That means you're following. So let's proceed. Now, what we can see here are examples of refrigerant or nuclear reactors. So you can see that here, some of the things they use in cooling, some, not all actually, some they use in cooling are as coolants or as refrigerants. You can see that here you have nitrogen, you have argon, you have hydrogen, and so on and so forth. So one of them here is carbon dioxide. So all these are examples of coolants or refrigerants. So carbon dioxide is also a very good example of refrigerant that we can use as cooling effect, and then also to preserve perishable goods. So now quickly we move to let me add these people that are waiting. Some people are waiting in the chat room. Are waiting. I think I've added all of them now. Admit all. Okay. Now, laboratory carbon monoxide. Laboratory carbon monoxide. Here we are talking about the laboratory preparation of carbon monoxide. So as we have said that carbon monoxide is also known as carbon 2 oxide and is another oxide for carbon. So how do we take the preparation of carbon monoxide? So we have how is it prepared in the lab? It can be prepared in the laboratory by, let me remove this please, it's causing, okay. It can be prepared, Amira, please unmute yourself, please. Mute yourself, Amira. Thank you. Yeah, it can be prepared in the laboratory by adding conc sulfuric acid to crystals of ethyl dioic acid. So how do you prepare carbon monoxide or carbon 2 oxide in the lab? So what you do is you react a special type of acid called ethyl dioic acid, right, with concentrated sulfuric acid. You remember what sulfuric acid is, right? So what is the name? What is the IUPAC name of sulfuric acid? Anybody?
Sulfate.
H2SO4.
Yes, H2SO4. So what's the IUPAC name?
Tetraiodosulfate 6 acid.
Yeah, beautiful. Tetraiodosulfate 6 acid. So that's what we also call sulfuric acid, right? So when you react concentrated sulfuric acid on crystals of ethyl dioic acid, so this is the chemical formula of ethyl dioic acid. So it's hydrated. So when that is done, it's going to lead to the formation of CO, CO2, and water. So that means three products will be formed. You'll be having CO2, which is carbon 4 oxide. You'll be having CO, carbon monoxide, and you'll be having H2O. But note that the function of conc H2SO4 here in this reaction is that concentrated sulfuric acid only act as a dehydrating agent. So it's only going to remove the water present in it and the composition is going to occur. It serves no other purpose but as a dehydrating agent. So let's look at the equation. Now you can see it here that ethyl dioic acid, when you add conc sulfuric acid to it, what's it going to give us? Carbon monoxide, carbon dioxide, and water. These are the three constant products. But what we actually need in this reaction, right? The product we need is carbon monoxide. We don't need carbon dioxide. Mind you, water is going to be in the liquid form, and as a result, water is going to remain. But carbon dioxide and carbon monoxide will escape as gases, right? So you need to remove carbon dioxide and leave carbon monoxide, trap it, and then use it for whatever you want to use it for. So how is that done? Now, a mixture of equal volumes of carbon dioxide and carbon monoxide is produced from the reaction. So the mixture is then passed over concentrated potassium hydroxide solution to remove the carbon dioxide present. So what do we mean? What do I mean here? So if you want to remove any trace of carbon dioxide present in the mixture of the product, that means you have carbon monoxide, carbon dioxide. These are the two things you are talking about. We said that water is in liquid form, so water is going to remain, but the two gases that will escape are carbon monoxide and carbon dioxide, right? So between the two, you only need carbon monoxide. So what you do is you need to get rid of carbon dioxide, and you can get rid of carbon dioxide by simply passing the mixture of the gases over what? Conc potassium hydroxide solution. So when you do that, potassium hydroxide solution, right, will remove any trace of carbon dioxide that is present, and you are only going to be left with carbon monoxide. So that's just a simple way by which the preparation of carbon monoxide is done in the lab. Is this understood? Is
Yes,
that
sir.
understood? Okay. Now,
Yes.
carbon dioxide is collected over water as the gas is insoluble in water.
Yes, sir.
So, sorry, what is supposed to be here is carbon monoxide, not carbon dioxide. That's an error. So, carbon monoxide is collected over water because it is what? Insoluble in water. Because if the gas is soluble in the water, you can't pass it over water. If you do a mistake of passing anything that is soluble in water, so what's going to happen? It's going to mix with water and you will not be able to collect it. You get it? But if that substance is insoluble in water, no matter how you add it, what will happen? It's going to escape. Just like carbon dioxide too. You know, no matter the amount of carbon dioxide you press in your carbonated drink, when you open it, what will happen? It's going to escape, right? Even though you are going to have some of the traces of carbon dioxide that will still mix in the carbonated drink and in the solution, but majority of it will escape, right? So also carbon monoxide, it is insoluble in water. No matter how you add it in it, it's not going to mix with water, and as a result, it's going to be collected over water. I hope that makes sense. I hope that makes sense.
Awesome.
Okay.
Yes, sir.
Now let's quickly look at the physical properties of CO, carbon monoxide. Number one, carbon monoxide is a poisonous gas. It's a colorless gas with no smell. Carbon monoxide is also insoluble in water, right? Carbon monoxide is denser than air. Okay, let me quickly tell you how to know if a particular gas is less dense than air or denser than air. Please, let's put our mind together. I want to explain that quickly so that you will know if you are given any gas, if you want to, okay, this gas, is it denser than air or less dense than air? Please, I want everyone to pay attention to this because I will explain it abstractly. You know, I don't have anything to write on. Just pay attention. If you pay attention to what I want to see, you will get it. Now, the vapor density of air, what I mean by air is AIR, air, okay? The vapor density of air is 14.4. Is that understood? Please, did you get what I just said now? The vapor density of air is 14.4. Please, if you want to write it somewhere, you can do that so that you not forget. Now, when you have any gas and you calculate the vapor density of that gas, and the vapor density of that gas is more than 14.4, that means that the gas is denser than air. But if the vapor density of such gas is less than 14.4, that means that gas is less dense than air. Does it make sense?
Yes, sir.
Now, the next question now is, how do you calculate the vapor density of any gas given? How do you calculate the vapor density of any gas? Listen attentively, you get that. You remember how we do the calculation of molar masses, right? For example, if I want to calculate the molar mass of CO, I will say the atomic mass of carbon is 12 plus the atomic mass of oxygen is what? 16. So to get the molar mass, I'm going to add 12 plus 16, right? Which is going to give me what? 12 plus 16 will give me what? 12 plus 16 will give me what?
28.
28, right? 28. Now, because it is giving me 28, if I want to get the vapor density, what I'm going to do is I'm going to divide it by what? I'm going to divide it by 2. Okay? Are you getting my point?
Yes, sir.
I think
Yes,
there
sir.
is. I think there is a mixed up somewhere here. I think there is a mixed up somewhere. This gas is supposed to be CO is supposed to be less dense than air, not denser than air. Let me just explain that so that subsequently we'll get it appropriately. Now, to get the vapor density of any gas, what you do is molar mass divided by 2. So if the vapor density of a gas, for example, is let's say 44, okay, like CO2. CO2 is 44. That's the molar mass. So when you divide it by 2, you are going to get 22, okay? So that 22 is now your vapor density. So you will now compare the vapor density of the given gas with the vapor density of air. So if the vapor density is now greater, 22 compared to 14.4, so 22 is more than 14.4. So you say that the gas with the vapor density of 22 is denser than air, which is 14.4. Do you get that?
Yes, sir.
Yes,
Yeah,
sir.
so that's generally how to get gases that are what? Less dense or denser than air. So number 4, this is just the fourth property, the fourth physical property of air. It is formed as a result of incomplete combustion of fuel and can commonly be found in gas exhaust. So that's where you can find it, and it's as a result of mainly obtained as a result of incomplete combustion of fuel. Okay. Here now, finally here, we have chemical properties of CO. What are some of the chemical properties? Number 1 is that it has a high binding ability to hemoglobin. So carbon monoxide binds more readily to the hemoglobin in the red blood cell than oxygen does. So it's going to form what we call the carboxyhemoglobin, which is stable and thus prevent the red blood cell from carrying oxygen. So
Excuse me,
when
sir. What is hemoglobin?
hemoglobin, okay, hemoglobin is found in the red blood cell. It's found in the blood. So in your blood, you have different, blood cells. You have the red blood cell, you have the white blood cell, you have the blood platelets, right? So in the red
Okay.
blood cell, you have a particular pigment called the hemoglobin. And the function of the hemoglobin is that it captures any trace of oxygen that you inhale and disseminate it to all parts of the cells in the body. So that's the function of the hemoglobin. But when an individual inhales CO, which is carbon monoxide, what CO will do is that the hemoglobin in the blood will attack the CO, right? So it's going to capture the CO and prevent the hemoglobin of, capturing any trace of oxygen, because the CO carboxyhemoglobin will now be deficient of any oxygen. So the CO is going to react with any trace of oxygen, and then it will leave the system devoid of oxygen, and the person can then suffer from suffocation, dizziness, and then the person can actually die. So that's one of the disastrous effects of CO. That's why we say CO is actually a poisonous gas, because it can easily lead to dizziness, suffocation, and eventually death. So that's one of the,
Excuse me, sir.
yeah.
What does the hemoglobin cause in the blood?
I've said that. I said the function of hemoglobin is that it captures any trace of oxygen present in the blood. I mean, that you inhale, right, when it enters into the blood, and disseminate that oxygen to all cells in your body. The cell in your body, all part of the cell in your body. The oxygen is disseminated through what? Through the hemoglobin. Because the hemoglobin is what
Okay,
captures that oxygen. Is that
okay,
understood?
sir.
Okay.
Yes, sir.
Now, number 2, the second property of CO, chemical property of CO, is that it undergoes a combustion process. So carbon monoxide burns in air with a blue flame. So when it burns with a blue flame to form carbon dioxide. So carbon monoxide combines with oxygen to form carbon dioxide, and we can see the equation below, right?
Mr.
So we
Salam,
have, okay,
what do you mean by blue flame?
blue flame. Blue flame is a
Yes, sir.
blue. What I mean by blue flame is, a flame. Flame, when you light your gas, right? Your cooking gas at home, it comes out with a flame. Look at that flame. Part of the flame is blue,
Uh,
isn't it? Some
Yes,
can
sir.
be so when you burn, when you do the combustion process, you are going to have completely blue flame. No red, no, you're going to get blue flame. The flame is going to be blue. So that's what they are talking about. So
Okay, sir.
when carbon monoxide reacts with oxygen, it gives you completely blue flame. Is that clear?
Okay, sir. Yeah.
Just explain
Now,
it to me.
the third property is that carbon monoxide acts as a reducing, it has high reducing ability. So, for example, it is a strong reducing, it has a strong reducing agent. It is a strong reducing agent. Why? It is able to reduce some oxides like lead 2 oxide or iron 3 oxide to metal, and this is extensively used in, you know, metal industries where we have extraction of metals. If you want to do the extraction of iron or the extraction of lead in the industry, they use carbon monoxide a lot to reduce the oxide to make sure that they get the metal itself. So these are some of the chemical properties of um, so this marks the end of our class on this section. So we will quickly move to our what is it called? Our Google Classroom to continue our section. Okay. Are you listening, everybody?
I see,
Okay,
sir.
before we move to the Google
Sir,
Classroom, yeah, somebody saying something.
are you going to give us the note on the Google class?
Yes, I will do that, no problem. So if you have,
Okay, sir.
do you have any question? Question time. If you have any question, please let signify by raising your hands. Or you can just talk. You can permitted to talk if you have questions, please. Unmute your mic and talk so that we can take any question, please. No question?
No. Yeah.
Okay, somebody is saying something.
Um, I don't quite understand the last slide on how it is used as a reducing agent.
Okay, let me go to the last slide. Any other question? Before I start asking my own questions. Now, here we say that one of the chemical properties of CO, carbon monoxide, is that it acts as it has a reducing property, so it's a very strong reducing agent. Now, what we mean by that is that you have some metals, when you get them in their ore form, that means in their natural form, they always have oxygen in them. Okay. Some of these metals include iron oxide, like iron 3 oxide. It is called bauxite. Okay. So how do you get it in nature? When you go to the ground where they are in large quantity, you cannot get iron as only iron, Fe. So it's always combined with oxygen. So in the industry, whenever they want to get our iron in its pure form, what they will do is they are going to react CO over what? Over the iron oxide, which is the natural form of the ore of iron, the natural form of iron in the earth. So when that is done, it's going to reduce that oxygen that is present in the iron, which is iron oxide. It's going to remove the oxygen and only make use of what? Iron, and only produce iron. So that means it is reducing, it's serving as a reducing agent. It is reducing the oxygen and only producing what? Iron. You get that? So that's why we said it has a strong reducing ability. It's a strong reducing agent. So the same thing can be done for lead oxide too. Lead oxide, when it's obtained in nature, when you react CO over it, it's going to reduce it and form lead only. When you have lead oxide and you react CO over it, it's going to form iron only, which is what is extensively used in the iron making industry or metal making industry for some of their metals. So I hope that is clear. All right? Is that understood? So is that understood?
Yes, sir.
Okay, my own question now. My own question. Can I ask my question?
Yes, sir.
Okay. Now, what are the major oxides of carbon?
Monoxide and dioxide.
You said?
monoxide and dioxide.
What monoxide? I don't understand what you mean by monoxide.
And carbon monoxide.
You have to put carbon there. Carbon monoxide and carbon dioxide. Thank you. So carbon monoxide and carbon dioxide. Another name for carbon monoxide, the IUPAC name of carbon monoxide is carbon what?
Carbon 2 oxide.
Thank you, carbon 2 oxide. Okay, what about the other name for carbon 4 oxide? Sorry,
Carbon dioxide.
carbon dioxide. Thank you.
Carbon.
Okay. Carbon dioxide. Now, second question. Second question. Why is... Are you listening?
Yes,
Hello,
sir.
listen. The next question, please. Who can describe for us the laboratory preparation of carbon 4 oxide? How do you think carbon 4 oxide can be prepared in the lab? I'm waiting for your responses.
When you mix dilute acid with calcium carbonate 4.
Awesome, awesome, awesome. By mixing dilute acid with what? Carbonate 4. Can you give me, who can give me an equation and balance that equation and give me the reactant and the product for the preparation of carbon 4 oxide? Anybody? Somebody has given us hints already. I need a female this time around. A female, a female. A female to give us an equation, right, that describes the preparation of carbon 4 oxide. Nobody's saying anything, no. Females, are you not there? Apampa Mardia. Mardia, Oya talk. Latifa Tijani. Zainab. Balogun. Oh yeah, I need your responses. Give me an equation that supports the laboratory preparation of carbon dioxide in the lab. Somebody has said it that the carbon dioxide can be prepared in the lab by reacting dilute acid with calcium carbonate 4. So tell me, give me an equation to show that. Just say that orally. I'm waiting.
HCl plus C, 2HCl plus CaCO3 to give us CO2 plus CaCl2 plus H2O.
Very good. CaCl2 plus CO2 plus H2O. Beautiful. That's a very good attempt. Who said that? Who gave us that response?
Dear.
My dear. Oh, I thought you were sleeping before. Alhamdulillah, you are awake now. Okay, another question. The last question. Can I proceed?
Yes, sir.
Okay. Now, why do you think carbon monoxide is considered as a poisonous gas?
Me.
Continue. Yes, Adiabo.
Because when it is inhaled, it comes.
Adiabo.
Carbon monoxide. Sir, when carbon monoxide is inhaled, it comes. My brother is disturbing that one.
Go ahead, go ahead. Who is Oluwatoyin Tijani? Is it Latifa?
Can I chat?
Yes.
Okay, go ahead.
Well,
Yes, sir.
because carbon monoxide, when it's inhaled, it displaces the oxygen in the body.
It does what?
It displaces the oxygen.
How?
Sir. Salau.
You are right, but not completely. Okay, so
Salau.
yeah, Latifa, let's hear you.
Because it displaces the oxygen in the body because it has more binding ability than oxygen, and it occupies space, and the person, if the person can suffocate and die. It
Okay.
forms carbon.
Yes, that's exactly the word I want to hear. It's already in your screen, it's still in your screen, forming what? Carboxyhemoglobin. So which prevent the red blood cells from carrying out for carrying oxygen. So it's going to make the blood to be devoid of any trace of what? Oxygen. Okay, that's a good attempt from everyone. Okay. Now, who can tell us the procedure used in the preparation of CO, that is carbon monoxide, in the laboratory? How do you prepare carbon monoxide in the laboratory? We want to see those who are following. How do you?
Is it carbon monoxide or carbon dioxide?
Carbon monoxide, monoxide.
I wasn't.
Nadia,
When you react
Nadia has
concentrate
not been talking. Oh, okay, somebody is saying something.
when you react concentrated sulfuric acid with methanoic acid,
Methanoic or ethanedioic acid. Ethanedioic acid. Yes, you got a very good trial. But it's sulfuric acid, conc sulfuric acid with what? Ethanedioic acid. Okay. So ethanedioic acid. So what is the function? What is the function of ethanedioic acid there? I mean, the function of sulfuric acid there. Aisha Anakoya. Talk. Aisha Anakoya. Yeah, it's your turn to talk. I don't think Aisha is here. I can see her and she's not talking. Unmute yourself and talk now. What is the function of sulfuric acid in the preparation of CO? It acts as what? I said it. You are coming. Where are you coming from? You are checking your textbook. I know. You are checking your textbook. Oh yeah. Nadia. Yeah, give us your answer.
It exerts a dehydrating action.
You said that. You said what? I didn't get what you said. I didn't get what you said. Aisha, I didn't get what you said though. You said something. I could not get it.
It exerts a dehydrating action on it.
After checking it from your textbook. Dey your body. Mariam Absalam. Tell us two uses of carbon dioxide. Two uses of carbon dioxide. Mariam Absalam. Oh yeah, Mariam.
Her name is Aisha.
No, I said Mariam Absalam. She's there now.
There's no Mariam Absalam in the class.
Sorry, Aisha. Sorry, I'm calling your sister's name. Aisha, yeah. Two uses of carbon dioxide. Can anybody assist her?
It can be used as an extinguisher,
Yes.
and they can be used for carbonated drinks.
Thank you.
Refrigerant and coolant.
Thank you very much. Thank you very much. Amira Awesu. Amira Awesu. Oh yeah, your own turn. Amira, state 2 chemical properties of, okay. State 3 physical properties of carbon dioxide. State 2 physical properties of carbon dioxide. Three. Or tell us the ones you can remember there. I hope Amira can hear me. Except you are checking your textbook. See, you know those that are paying attention, those that are not. Ali Imam. Yeah, tell us. Physical properties. Physical properties.
Can I help?
Okay, go ahead.
A colorless and odorless gas, and it's denser than air.
Thank you very much. It's a colorless gas, odorless gas, that's one. Colorless gas, odorless gas, that's one. Then it is denser than air, that's two. Any other one? It's only slightly soluble in water. It's only slightly soluble in water. Yes, it's only slightly soluble in water. Thank you very much. So we're going to stop here on then the remaining 10 minutes we use it on our Google whatever. So I'm going to send the notes and every other things on your Google Classroom. Okay. I hope you enjoyed the class. Any reaction, positive or negative, before we end the class? Your comments. Did you enjoy the class or not?
Yes, sir.
What can we do better? What can we do better to make it more interesting?
Should not be by 8 o'clock in the morning.
I didn't get that. Somebody saying something. What can we do better? You said? Okay. No problem. Let me pause it. And inshallah, we'll move to our Google Classroom. Thank you.